Okay, so in the next section, we're going to talk about the properties and changes in matter. So every substance, whether it's an element or a compound, has a characteristic property, and chemists use properties to distinguish between substances and separate them. Now, most chemical investigations are related to or depend on the properties of these substances. So what we want to be able to do, there's three things I want you to be able to do. Number one is distinguish between a physical property and a chemical property of matter, and give me some examples of each one. Number two is, now we've talked about density. We had a lab on density. I want you to be able to perform some calculations involving density. For example, if I give you the mass and volume, you can find the density. Or if I give you the mass and the density, you can find the volume. And we've done this about thousands of times. If you remember, you should be really great by now about manipulating these equations. And then the last thing is to describe properties and give examples of different kinds of properties. So, what is a property? Well, a property is a characteristic that defines an entire group of substances. It can be used to classify an unknown substance of matter as a group. For example, one large group of elements is the metals. And one of the distinguishing properties of metals is that they conduct electricity, and they conduct heat very well. They're shiny. So these are examples of properties. So if it's an unknown element and is tested and found to conduct electricity, well, then it's metal. And properties can help reveal the identity of an unknown substance. Now, if you just identify one property, that usually can't help us determine what an unknown substance is. It takes several properties or combinations of properties to really define or compare what a substance actually is. So let's start with physical properties. A physical property is a characteristic that can be observed or measured without changing the identity of a substance. Okay, so physical properties describe the substance itself rather than describing how it can change into other substances. And here in this little graphic, I've given you some examples of physical properties like color, shape, mass, and volume, or the boiling point, melting point, density, volume, weight, magnetic properties, the state of matter, whether it's a solid, liquid, or gas, or textures, is it rough or smooth, luster, how shiny it is, ductility, not ductility. Ductility is the ability to be drawn or pulled into wire. There's also malleability. Malleability is the ability to be hammered or pounded into thin sheets. So I want you to learn these are some basic physical properties of matter. Remember, they describe the substance rather than describing how it changes. Now, a physical property, as we said, is a property that can be observed or measured without changing the identity. And a physical change is a change in the substance that doesn't involve a change in the identity of a substance. For example, if you take bread and you put it in the oven and you bake the bread, then you cannot unbake the bread. Okay, you cannot unbake the dough. So it goes from dough into bread. But if you take water and you boil the water, it's still water. Whether you're boiling it or whether you're freezing it, it is still water. So that would be a physical change, where baking bread would actually be a chemical change. Examples of physical changes would be grinding or cutting or melting or boiling material, and none of those things that you do to it change the substance. A second kind of property is a chemical property, and a chemical property is a property that relates to a substance's ability to undergo a change that's going to actually change it chemically or change it into another substance. Chemical properties are easiest to see when the substances react to form new substance. For example, the ability of charcoal to burn. When we burn something, we're actually combining it with oxygen and changing it into another substance. So when you take charcoal and you burn it, it combines with oxygen in the air to become a new substance, carbon dioxide gas. And after the chemical change, the original substance, carbon and oxygen, are no longer present. A different substance is present and has been formed. So other examples of chemical properties include the ability of iron to rust by combining iron with oxygen, or silver to tarnish by combining it with sulfur. So a change in which one or more substances are converted into different substances is called a chemical change or a chemical reaction. So let's compare. So a physical property is something that you can recognize just by looking at it, its shape, its color. For example, you recognize your friends by their physical properties such as height or hair color and weight. And when playing sports, you choose a ball that has the right shape or mass suitable for your game, like mass and volume. The mass and volume and density are great examples of physical properties. By the way, you can also describe matter in terms of the absence of this physical property, like something is colorless, like, for example, water or alcohol. It's colorless, and that is a physical property of that matter. And I want you to also remember that a characteristic of any pure substance is its boiling point or its melting point, and they're constant. Okay, so these are physical properties. Density, again, is a physical property. And to review, density is the amount of matter that's contained in a certain volume of a substance. Somebody might ask you, what is more dense, a pound of feathers or a pound of lead? Now, if you have a pound of feathers, you're probably going to have a whole sack full of feathers. That's a lot of feathers in a big sack. But if you have a pound of lead, you can probably hold a pound of lead just in a single little shot in your hand. So the lead is much more dense because it has more atoms contained in a smaller amount of volume. But a pound of feathers, you're going to have a lot of volume, but the same mass. One other thing to remember about density is that density is going to determine whether something will float or sink. Now, an object's going to float when it has a density less than that of water, but an object will sink when it has a density more than water. So if the density is greater, density of a substance is greater than the fluid it's in, okay, it will sink. But if the density is less than the amount of fluid that it's in, then it will float. And the way to calculate density is density equals the mass of that substance, and that's measured in kilograms, remember, over the volume. And that's measured in cubic meters. Okay, so mass is in kilograms and volume is in meters cubed. Now, another way to determine the mass or to express mass is grams per milliliter. Okay, so that's another way of expressing density. Those are both units for density. So let's take a look at a couple of examples. If we have 19.7 grams of ice and we know that the volume of that 19.7 grams of ice is 10 milliliters, then what's the density? Well, what we know is, we know that the mass is 19.7 grams. And we know the volume is 10 milliliters. And what we're looking for is the density. So let's write the formula. Density is mass divided by the volume. So the mass of the ice, 19.7 grams, and the volume, 10 milliliters. Okay, and in your calculator, punch in 19.7 divided by 10, and you get the density is 1.97. You have grams in the numerator and milliliters in the denominator, and that would be your density, 1.97 grams per milliliter. And grams per milliliter is density. So let's take another example. You have a piece of tin, and it has a mass of 16.52 grams and a volume of 2.26 milliliters. What's the density? So what do we need to know? Well, first we need to know the mass. The mass, write it down, 16.52 grams, and the volume is 2.26 milliliters. And what we're looking for is the density. Okay, so let's write the formula. Density is equal to the mass divided by the volume. So write in the mass, 16.52 grams. Write in the volume, 2.26 milliliters. And then do your division, and let's see what you get. And I'm just holding for you. You can pause if you need to. And what I come up with is 7.3 grams per milliliter, and that would be the density of this substance. So let's look at another one. Okay, so here's a chance where you get to move the equation around a little bit. It says a piece of metal has a density of 11.3 grams per milliliter. So we're going to write that down. Is the density equals 11.3 grams per milliliter. And it has a volume of 6.7 milliliters. So the volume is 6.7 milliliters. What is the mass? So we're looking for the mass this time. Now I'm going to start by writing the equation. Density equals mass divided by the volume. So what we want to know is, what is the mass of this tin? So what are we going to do? Well, we've got to get rid of volume. And if you notice on the right-hand side, volume is in the denominator. Okay, so we want to get rid of the volume. So how do we get rid of the volume? Well, if we want to get rid of the volume, we have to multiply both sides by the volume. We're going to multiply both sides by V over 1. Okay, that makes the volume cancel. So density times volume equals the mass. So let's write that out. Well, we know the density is 11.3 grams per milliliter. And we know that the volume is 6.7 milliliters. Okay, milliliters, that's like 6.7 milliliters over 1. Milliliters are going to cancel, so we're going to multiply 11.3 times 6.7. And let's try that again. 0.3 times 6.7, and we come up with the mass is 75.7 grams. Okay. This is just simple algebraic equations, moving those equations around. So in this equation, it says a substance has a mass of 35 grams and a density of 0.087 grams per milliliter. What's the volume? So this time we're trying to just get the volume by itself. So what do we know? Well, we know the mass is 35 grams. And we know the density is 0.87 grams per milliliter. So what is the volume? Well, this is one of those ugly problems. Density is mass divided by the volume. So we've got to get the volume by itself. So the first thing I think I would do is multiply both sides by the volume. Okay, volume over 1. Okay, so dV equals the mass, because we had the volume canceling there. Now we want to get the volume by itself, so if we divide both sides by the density, we get volume equals the mass divided by the density. There we go. Now it's going to be easy cruising, just easy sailing from here. So the mass is 35 grams. The density is 0.87 grams per milliliter. Grams are going to cancel. So 35 divided by 0.87 gives us 40.2 milliliters. And that is our volume. Now notice that what we really did was just switch places between the density and the volume. We just really just switched places there, and that made it a lot easier, right? Okay, so that is how to calculate the density. So I'm going to give you a little practice calculating densities, and you go through this as many times as you need. We'll do one more example just to make sure you've got it. So in this example, it says a substance has a density of 1.55 grams per milliliter and a mass of 55 grams. What is the volume? So let's write out what we know. We know the density equals 1.55 grams per milliliter. And we know that the mass is 55 grams. And what we're looking for is the volume. This is another one of those more difficult problems. So density equals the mass divided by the volume. Now a shortcut here, remember, is if we have, we're looking for the volume, which is in the denominator, we can just actually make these guys switch places. So volume just equals the mass divided by the density. This is a really easy little switch. We just switched mass and density. So let's just plug straight in. So mass is 55 grams, and the density is 1.55 grams per milliliter. Again, grams are going to cancel. 55 divided by 1.55. If you do that, it's 35.5 milliliters. And there's our answer. There's the volume. So I'm going to give you several little problems to work out, and you're going to try those, and then we'll come back. And what I want you to remember in summary is to go back and look at what are physical properties, what are chemical properties, how do you tell the difference between physical and chemical properties, be able to give me some examples of physical and chemical properties. That's what we'll do for our quiz, is be able to tell the difference between those, and also be able to calculate densities or masses or volumes if I give those to you, and we'll do several little practice problems with those. Feel free to go back and review this video as many times as possible, and good luck with your work, and if you need anything, just ask me.